All right, chat, we've got this goofy ass language, and unfortunately it doesn't support any form of asynchronous programming because it's a C3. It's supposed to be an evolution of C, but we kind of need asynchronous programming, honestly. We do kind of need asynchronous programming because we're doing a little bit of asynchronous networking. And so I was thinking, how can we approach asynchronous networking in C3? And I decided, let's try to implement the abstractions that a lot of languages out there implement. And the abstraction is actually future, or in some languages it's called promises. I think in JavaScript they're called promises, and in Rust they're called futures or something like that. So we can actually look up like Rust future promise or something like that, hoping that maybe Google, yeah, so they're called also promises in Rust. I didn't know that, but I feel like they're basically the same thing, aren't they? A promise is a way of doing the work in the background. The promise in this library have the same feature set as those ECMAScript 5. ECMAScript is JavaScript, by the way. It's an official name of JavaScript because freaking Oracle squatted the copyright for the name JavaScript, and now nobody can actually officially call it JavaScript, even though everyone calls it JavaScript, Oracle being an asshole. It's actually kind of funny how somebody made a petition to like ask Oracle to free the copyright on the word JavaScript, and it made me laugh so fucking hard. It's just like people who decided to make that petition don't understand what kind of company Oracle is. Excuse me. Oracle is an evil company, and I actually mean it. They know that they're evil, and they're proud of it. They're comically, cartoonishly evil, like fucking straight up. So they will listen to that petition, and their answer will be, "Fuck you. We're gonna keep it until the end of the fucking universe because fuck you." They are like that. I'm not fucking joking. They are cartoonishly fucking evil company. They will just fucking do that. So for them, this kind of petition is an encouragement to actually not do that. So it's just like, I don't even know. I don't even know what that person was even thinking. So, but Oracle would never fucking do that. They would never fucking do that. Still one step behind Microsoft? Probably, right? It's kind of difficult to compare in terms of evilness, who's more evil, Oracle or Microsoft. But Oracle is pretty much like a straight up evil company. So anyways, right. So, and yeah, promises is, you can think of promises as sort of like a piece of work that you need to finish, right? And if you think in terms of like maybe an interface, right? So let's actually maybe create some sort of a problem here. I'm going to do a C3 futures. We're going to call them futures. Or maybe for the sake of consistency, we're going to call them promises. Right? I don't know. Right, so I'm going to do C3, and I'm going to import the standard IO because I want to be able to print on the standard output. Right, so if you think about in terms of like interface, right, unfortunately interface is not highlighted in my mode, but imagine that interface is highlighted, okay? So promise is sort of like, it has one method. Right, so which you have to periodically call, right? So let's call it poll or something. Sometimes I call it update, right? So, but maybe you can call it poll. It may accept some stuff. It may accept some sort of data, and one of the things it will return you some sort of a boolean that says that whether the task or some piece of work has been finished or not. So during working on that thing, obviously it can fail, right? And essentially that's about it, right? So think about it like interface. And this interface can be implemented by all sorts of tasks, And another thing, another sort of operation that you can do on the promises is sort of like chain them together. Right, so as soon as one task is finished, another task has to be sort of called or created or something like that, right? I don't really know how exactly to call that, but so think about it like chain is going to be a function, right? So it's a higher level function, and so it returns another promise, right? It returns the promise that will be created, and then how can I call that? I suppose F, and it accepts the result of the work. Right, so the result of this promise, right, will be passed to this function as soon as this promise is finished, and the new promise that is created out of this function is going to be the new promise. So you can sort of chain them together. And once you somehow acquired the promise, right? So somehow you acquired the promise, what you're supposed to do, you're just supposed to sort of call the poll in a loop, right? While it is false, right? You sort of like polling this task, right? So it is expected that a single poll is not going to take too much time. Right, it's a very simple operation, but you're doing the whole work that the promise is trying to do in these small incremental operations, right? You don't do it at once, you do it in a small incremental operations. Why it is like that? Well, if you have two promises, you can actually work on them sort of simultaneously. You can sort of like switch between them. Okay, I'm gonna work a little bit on this one, and then I'm going to work a little bit on this one. Right, so I'm kind of working on them simultaneously, but there's no multi-threading involved in here. Right, sort of I like round robin between them. So I worked a little bit on that, a little bit on that, a little bit on that, and a little bit on that. And because of that, it creates this feeling of working simultaneously. Right, it creates a feeling of working simultaneously, but usually it's working in a single thread. This kind of stuff is very useful for input-output for I/O, right? Because I/O usually doesn't, take up any CPU resources or anything like that. You usually wait on I/O, and while you're waiting on I/O, you might do something else, right? So, and that's why you want to split up I/O operations into these sort of small, simple chunks, between which you can do some useful work, right? Between them, you can do some useful work. So, and so essentially, if you want to construct like a bigger feature, right? So you can chain essentially like this, right? So I want to say that I'm going to accept the result, right, of this sort of feature, right? The result of this feature. Then I'm going to process the result of that feature, and then that should create sort of like a new feature, right? So maybe I'm gonna pass that result to another operation that is also going to take some time, right? So for example, write to socket, right? So the result will be written to socket, but the operation itself also returns a promise. I'm going to return that promise, and all of that is chained together, right? So you sort of you can combine promises and stuff like that. I don't really know, like, is there any interface for the promises in Rust, right? So maybe we can draw some inspiration from Rust. Does it even implement any interfaces? Okay, so here's then. Right, so and then is usually used for chaining different promises, right? So it accepts actually several callbacks in here. Oh, it's one for the, the usual callback and another one for the error callback. That's understandable. And here you go. Right, so callback is F1, and if you take a look at F1, right, so it accepts the result of this feature, right, and yeah, and returns you a result that is going to be passed along, or something like that. So, but does it have something like poll, right? Does it have an equivalent of poll? It has a reject or some other stuff. Maybe there are some implementations. So implement promise. Okay, so this is a structure that is the promise, but also there should be some sort of an implementation. No, it doesn't look like it. It goes actually back. Oh, it's just a regular implementation. I don't really see a poll in here, so there is a race. But usually these kind of things, they do have a poll. Maybe we can take a look at the implementation here. So here is the source code. Poll system is feature promises are event-based. Ah, so that's the difference between them. Right, so because usually I think about promises and features as the same thing. Right, so okay, in Rust they are different. Okay. Apparently there is some sort of difference between feature and promises, right? Okay, it's event-based. Okay, makes sense. But from the, yeah, so, and there you go, here is the poll. Okay. You see, we learned something, right? So we learned something. Apparently there is like a fundamental difference between promises and features, right? I always thought about them as the same thing, but promises are event-based, I suppose, right? Well, that makes sense, I suppose, right? So you have a promise and you assign a bunch of like event listeners to them, and yeah, but from the point of view of like combining them, they kind of work similarly, right? Problem is not the standard library. Apparently that was a crate. Ah, okay. As usual, classic. As in all of the programming languages, there's a confusion between terminologies and stuff like that. In any case, we're going to be implementing a thing that you can chain and thing that you can poll, right? So it doesn't really matter how it is called in which language and which terminology is correct one. Right, we're going to be implementing a pollable thing. So let's call it pollable. Maybe we're going to call it pollable, right? Is it good? Right, so it's a pollable and chainable thing. So anyways, but the thing is, I think for this kind of stuff, we'll need the mechanism of interfaces of C3, right? And the problem is that I don't know how the mechanisms of the interfaces in C3 work, right? So I never really needed them, but I think now I need them, and I think this is a good opportunity to actually learn them. So I need them because several things may implement this interface, right? Several things may implement this interface, and you also need a little bit of a dynamic dispatching between them, right? So, and as far as I know, that's how you implement dynamic dispatching in C3. It even has a dynamic method and stuff like that. Right, so let's actually experiment with interfaces in C3 and see how you even do all of that stuff. So what would be a classical example of polymorphism, right? Does anybody know? Maybe something like interface shapes, right? So interface shape, right? And it's going to maybe have a method name, right? So, and it returns the name of the shape. So let's actually go ahead and try to compile this entire thing, right, and see if it compiles. Okay, so that seems to be compiling. So if I understand correctly, interface is just like an ephemeral thing, right? You can't really create a shape like this, right? Well, you can, but then if I wanna assign something to it, right? So I can assign 2, right? It will tell me no, it is a actual type. Okay, so then if I want to create something like a structure circle, right, and then I want to say, I want this thing to implement the shape, right, how is it going to work, right? I think this is the syntax. The last time I checked it, I think that was the syntax. Yeah, there we go. So this is how we define a structure. You define a structure and you say that the structure implements that specific interface, right? So what the compiler will tell me in this specific case. Okay, so zero size structs are not permitted. Fair enough. So one of the things we can put in here, we can put a radius in here. Well, let's put a radius in here. Okay. So, and now if I want to create something like circle with a radius, obviously 69, right? So it's going to be radius. Radius, let's go. Okay. So that's pretty cool. You can only convert pointers to an interface like shape. That's finally something interesting, right? So because it's going to do dynamic dispatching, so because of that, I have to take a pointer. Can I take a pointer of a structure literal? This is a good question. To take an address of temporary value, you have to use @@. I think I vaguely remember that. Okay, shape was not fully implemented. Required method name needs to be implemented. Did you forget it? I didn't forget it. Sassy messages, by the way. Sassy messages. I really like that. I really like when the compilers actually sass you like that. So let's implement the methods. So the methods that we have to implement are the name, right? So this is going to be the circle. You can also implement things like area, right? So, but I don't remember how to compute the area over the circle. So let's not do that. So, and in here, we're going to just simply return the circle. So the circle, there we go. Okay, so the expected at least one power. Oh yeah, you have to do something like self, right? So you have to do self, and name must be marked as dynamic. Okay, so it has to be marked as dynamic. Let's make it dynamic. And there we go. So we created a method. So that means I should be able to just call name like this, right? All right, and did it run it? Oh, I should probably print it. Okay. So let's do something like this. So it's going to be S. Let's put the new line in here, and boom, this is a circle. Okay, that's pretty cool. So let's create more shapes. Let's create more shapes. So another one is going to be rectangle, and it's going to be a shape. And for the rectangle, I think we're going to have like a width and height. Width and height. So the reason why I'm doing all of that, I'm trying to get the gist of this feature, because again, I never used it before. This is literally the first time me using this thing. Right, so here's the rectangle. And does it compile? It seems to be compiling. The whole point of dynamic dispatching is to be able to store different types of objects in sort of like a same container and address them in a similar fashion. Dynamic is override then. I suppose it is like kind of override. So I suppose what learner was going for is some sort of an explicit syntax that tells you that it's actually required by something else or whatever. Like, I don't really know exact justification of this dynamic, but it's just like it forces you to have this syntax, right, for whatever reason. So anyway, let's maybe create a list, a dynamic list, right? I wonder if I can do something like this, right? So I want to have a list of shapes, right? And I want to just append some things into the list of shapes, right? Shapes, append. So we're going to append this thing in here and a rectangle in here, and it's going to be width, and height is going to be 420, obviously. The height is going to be 420. So, and I think I want to be able to do, I want to be able to, for each this thing, shape, shapes, like so, which I then take the names. So the point of polymorphism, like dynamic dispatching like that, is to be able to do this kind of thing. I have structures of like literally different size and different type. I put them in the same container and I iterate over them. This is the kind of semantic that we will need for our future promises or whatever this is. Right. So let me do the following thing. So IO print fn. So this is going to be S. And let's fucking go. Let's actually see. So what is it going to say? So yeah, we need to actually do std collections list, import std collections list, something like that. And there's no field append. So it's not append, it's probably something like push, right? It is something like push, I think. I'm surprised it just worked. I'm actually kind of surprised that it just works. What is the lifetime of this object? It feels like it's a temporary object, but since, for how long does it live, right? So because it feels like it might be living only for this entire thing, but apparently it lives for the entirety of this body. I think it's just allocated on the stack. Aspexity also does it with vtables. I think it is actually vtables. This is pretty much vtable-ish. All right, so this is very useful. This is like, feels like a higher level language like Java or something like that if you need this kind of stuff. Right, I think it's pretty useful. Only makes sense if it's located on the stack, yeah. I feel like if there might be a situation that the object actually died after this thing, but I'm pretty sure learner would make some sort of a warning to tell you that this object does not live long enough, because it's actually kind of easy to detect that you're trying to take a pointer of this temporary thing and store. No, it's actually not that easy, honestly. It's actually not that easy. So let me see. It's kind of difficult to tell. So does it live long enough, or is that an unsafe operation? It's a temporary value. Okay, so let's actually search about a temporary value. It doesn't really say much. Expression, attack address of temporary use. So temporary. Expressions work like in C with one exception. It is possible to take an address of a temporary value. This uses an operator like ampersand rather than this one. Consequently, this is valid. Okay. Well-defined behavior. No, it doesn't say anything if it's safe or not. It doesn't say anything if it's safe or not. So I might actually assume that here we're referring to invalid pointer actually. It allocates on a stack. Yeah, so this is valid code. Check the this is valid. Yeah, so but then it exists only for the entirety of this expression, so it will exist for the entirety of this call. I feel like doing something like that, right? So if I have a global pointer, right, and then I do something like foo int x, right, and I just store it in a global space, right, and if I try to do something like this, look, Foo pointer to 69. Right. I think trying to then access the P is going to be invalid. I feel like it is going to be invalid straight up. So is it just null? I think this is just null. So it has to go like this. We can try to do something like that. This is actually rather interesting. So I think, like, I have a hypothesis that this entire code works accidentally. It works completely accidentally. So we can try to take a look at the integer, and I'm going to just like dereference this entire thing. I wonder what's going to happen. Now it still works. Still freaking works, surprisingly. Yeah, so it could be something like that. It could be something like that. No way C3 UB. We can introduce something like bar. Right, so, and we can put this entire stuff in here, but put this one stuff in here. So in this case, it will allocate it in a separate variable, but then after that one, it may become invalid. Right, so let's actually see. Yeah. Okay. So the reference of a null pointer, because I never called it. Okay. So one more time. Nah, it still works. Can't you see the intermediate code? I could try, but it's kind of difficult. But that means I have to work on a smaller example, and that's too much of a rabbit hole that I don't have plans to go into. So I'm not going to go into that. I'm going to assume that doing something like that, where you pass a pointer to a temporary value and store that value for longer than a temporary lifetime, is some sort of a UB or unsafe operation. I'm going to be going off of that assumption, right? So that's going to be my assumption, essentially. And I think it's a fair assumption in this regard, right? So because it's like, you know, it's C-ish language. So because of that, I feel like this kind of stuff is not a good idea. This kind of stuff is not a good idea, but we can do some things like where we just define circle like this and a rectangle like this. Rectangle, right, and we'll just push the pointers to them, right, because we are 100% sure that they're gonna live long enough, right? So because they're gonna live for the entirety of the scope of main, right? So here's the circle, here's the rectangle, and so on and so forth. So we have a little bit of a polymorphism. That's pretty cool. All right, so now I understand how this entire stuff works, and let's actually go ahead and try to implement future, right? So the pollable object is the future, right? So let's call it future then, right? And because of that, I think I'm going to be renaming my folder in here. So this is going to be futures, right? So this is going to be futures. So let's create an interface future. And what's important about this interface is it's going to be pollable, right? So it's a pollable interface. I'm not sure if it's going to accept any data, but maybe it should accept some sort of a data, right? So, but maybe the data should be stored within the implementation of the future. It's kind of hard to tell, like, where it has to be stored. But maybe if you're implementing some sort of like a graphics system for whatever reason, you want to be able to pass delta time, for instance, and like on each poll. So because of that, you might be actually want to accept the data. I just realized that it kind of reminds me about the async system that I built for Panim. Do you guys remember this thing? Right, so Panim, yeah, it's basically Manim, but in C. Yeah, it's kind of like that, right? So, but I mean, in C, I didn't have any interfaces or anything like that, right? But this one is kind of like that, because you can have several tasks that do different things. So we can even try to maybe clone it and just take a look at that, just so I can demonstrate what I'm talking about. Let's just git clone this entire stuff. Yeah, I wonder if it still builds. Well, I mean, it's using nob. That means it's always built. Right, because nob is designed to be reproducible and stuff like that. So nob.c. Let's just run nob. What does it need? Okay, so, and it actually built apparently. So what do we have in here? Do we have any subcommands? Apparently we don't have any subcommands. So I can do build panim, and I have to provide the DLL from which I'm going to be actually running things. And I suppose, where do I have the DLLs though? So here's the build. Oh, here they are. So I suppose one interesting one is going to be probe, square, template, Bezier, Turing machine. Right, so the Turing machine is the most interesting one, I suppose. libtmso. Yeah, there we go. So that's basically the animation. So all of that is written in C, by the way. So I'm not even joking, this is written in C. And it's like procedural animations and stuff like that. And so essentially it has a system of tasks that work similarly to futures. They kind of work similarly to futures. And they do a little bit of the small tasks that you have to poll in event loop, and that's why they appear simultaneous. But they're composable. You can do sequence of this task, you can run them in parallel, and so on and so forth. Right, so it works just fine. Yeah, exactly, right. So because if you write software in a simple way, with the least amount of moving parts, with the least amount of things that can bit rot, it just works over some time. It just works in 8 months. Can your JavaScript framework work in 8 months without any updates or without any changes or anything like that? Can it? All of the web infrastructure bit rots like the next week. So yeah, anyway. So I wonder how exactly it's implemented. So let's take a look at the TM. There should be a place where we define all of this task. I remember it quite vividly. Here they are, but it's just a table. But here's the scene. Here's an interesting scene. So it's a task sequence, right? It's a task sequence, and it combines the intro, then wait a little bit, then move the tape offset, then here's the group. That means you have 4 tasks that run in parallel, and so on and so forth. And the way I think you operate on this task is that you literally just update them. You just poll them. Do we have a poll? Yeah, so there is a task update, right? And you pass environment, by the way. Which is another sort of confirmation that we probably do need this kind of data thing, because usually poll operation needs additional data from the environment to make decisions and stuff like that. Right, and this plug update is also called periodically in event loop, right? And this entire thing sort of advances the tasks and stuff like that. It's kind of similar to that, I think. Right, so, and Panim seems to be working. Maybe I'll use that in the future for some things. I kind of abandoned the idea of making a video out of the Turing, not really abandoned. Didn't feel motivated, I suppose. I might actually resume working on this video, because it's kind of a cool video, honestly. I don't know why I stopped doing it. Kind of was feeling demotivated. It's kind of difficult for me these days to find any motivation. A lot of things just let me down every single day. So, but I mean, it's just a skill issue on my part. Anyway, so let's continue. So this is the poll, and there you go. How are we going to be acquiring the result of the data? So let's actually. Usually, this kind of thing is called map. Right, so usually it is called map, or maybe we can call it then. Yeah, I think it's a good idea to call it then. Right, and essentially it's going to be a function f which accepts some sort of a result. We don't really know what it is, and I wonder if you can maybe make this entire stuff sort of templated. But since we're doing a lot of dynamic stuff in here, maybe it's not about being templated, right? So yeah, I don't know. So in this entire thing, is it going to return anything? I suppose it is supposed to return a new future, right? It's supposed to return a new future. And since future could be, futures are pointers, I suppose you can actually null this entire thing. Let me actually try to run this entire stuff. Where is my compile? Right, so this is not how you do that apparently. Expected a parameter. All right, so can I just do something like that? How do I pass a pointer? Does anybody remember? I think it has to be something like a then function define something like this. I think that's how you do that. Right. Then function. Yeah, it's gonna be f. I swear to God, this is how you do that. It must be. Figure it out. All right, so it kind of forces you to do that, but maybe there is a way to inline the whole thing. What if I literally inline this entire stuff? Is it possible? Let me see. No, you can't inline that. You can't. You literally have to do that through additional depth. So that's pretty cool. So another interesting thing, can I do future f like null? Can I null this entire feature? Apparently I can. So the reason why I'm interested about that is that because if then function returns a null, maybe it's just an indication that you need to stop, right? I think. Or maybe stopping is going to be like one of the things that implements a future. You know what I'm talking about? Right, so we can implement something like done, which is the future, which always basically returns true, right, when it's done, right? So it's always done. Another thing, the thing it can store actually is its result, right? It's storing its result. It's storing its result. And so that's about it. So the way we're going to implement all of these things is this way, right? So done just simply always returns true. So this is like it's done. There's nothing to do in here. Then I didn't think it needs to do anything, right? So because it's kind of done. Though one of the things we can do in here, we can just obviously we want to probably accept self, right? We want to accept self. We can simply call on self result, but I'm not 100% sure. I'm actually not 100% sure. So let's see. But maybe this entire thing is not particularly great. So so it also kind of implies, by the way, it also kind of implies that then ability has to be implemented per specific instance of the future. So that's kind of the problem in here. Like it implies that. But maybe then ability has to be a separate thing that implements future. Right. So something like a struct then, which is a future by itself. Right, it is a future by itself, and internally it stores the original future, right? So the original future, and the then function that is going to call, when that future is done, something like that. I think that's basically the goal in here. So I'm thinking. So another interesting thing is that once the future is done, you need a way to get a value out of the future, right? You need to get a value out of it. So, I mean, the result. Because of that, we can introduce something like result, right? So that allows you to get the result out of that thing. So, and if we try to implement this kind of stuff, right? So it's a future then that takes the left one, then waits until it's done, and then applies the function on the result, getting another future, and acts that like the resulting future there. So interestingly, how can we do that? So this is the left one, and this is the right one. Something like that. So, and in here, this is then. Well, I mean, since then is a separate future, I don't think we need a method then, because the way you're going to become, you know, making it is by constructing this entire thing, right? You're going to be constructing this entire stuff. All right, so, and then result. Yeah, I think so far the only thing you need is just like a poll and result. Just poll and result. So furthermore, you might also return an error. So some sort of an error may happen if you try to poll. So that's also fine. So let's actually go ahead and do that. And the way I'm thinking about it, like if left is not equal to null, right? If left is not equal to null, we're simply going to be polling left, right? So, but it's also like a self, right? So it's a self, self left, and then self left poll, right? And we're just polling this entire thing, right? We're just polling this entire thing, and obviously it may return an error or whatever. So, but here is an interesting thing. If this thing became true, right? If this thing became true, we have to take the result of the left feature future, pass it to function f, and assign it to self-write. That's what we have to do. Right. So now suppose after that, we want to kind of forget the left feature. We're forgetting it, setting it to null, which means that this condition is going to be false and you're going to fall through to here somewhere. Right. So indication of self-left being null means that left finished executing. So now we're working on the right one. So what we're doing here is we kind of, first of all, we assume that self-write exists. It's not equal to null, right? So that's kind of what we're assuming here. And then we do a kind of a similar thing. Oh, by the way, so it falls, right? If it falls, we just don't do anything. So that means it's not finished yet. Okay. So then we do self-write and self-write poll. Right, so obviously we need to pass the data. I completely forgot to pass the data. I apologize for that. So we do self-poll, and if it succeeds or not succeeds, we can just return this thing always, right? We can just return this thing always. And when we take in the result, so here's an interesting thing. How do we react when we're trying to get the result when the future is unfinished? So what's the good way to actually do that? So ideally, I would like to somehow combine returning the result, indicating that the poll has finished, and error in one method. Ideally, I want to kind of get rid of the result. So one thing we can do, we can say that poll actually returns the result. Right. And so essentially, if this is null, that means the result is not ready. The result is not ready. And this option indicates an error, right? So we combine three things together, right? Indication that it failed or not failed, indication is finished, not finished, and the data itself. So it's all crammed together into the same thing. All right, so we can try to go that route because it kind of simplifies everything, right? It kind of simplifies everything. So that means we only need this kind of stuff. So the reason why I'm changing the interface is because I'm in the middle of actually designing it, right? So the fact that I'm not writing it right away is actually intentional. This is intentional because I don't know what kind of interface I need. I'm just trying different things, right? So, and so far, like I would like it to be just like a single method, right? But it's kind of difficult to achieve, but we'll see how it goes. So anyway, right, so if this thing is, oh, and look at that, right, so if it's unfinished, right, if it's sort of like finished, it gives you the result. Okay, so that means I need to restructure the whole thing in here, by the way. It means I need to restructure the whole thing. So if left not equal to 0, right, so here, what we have to do, we have to get the result. So we've got the result. And if the result exists, we pass that result to the inner f, which is this one, right? That creates us the right thing. And then we forget about the left thing. And in this specific case, we always return just null because it's not finished yet. We need to finish the right feature. Okay, so then in here, right is not null, and we keep polling the right one. Okay, so actually this one, I think this was a pretty good idea, right? To get rid of the second method for the result. Poll will also return the result as well. And obviously, like I'm using void pointers, right? Because like it's a very dynamic unknown thing. And furthermore, as far as I know, C3 has a concept of any, right? So it has a type any, interface and any type. The any type is recommended for writing code that is polymorphic at runtime where macros are not appropriate. It can be thought of as typed void. Any can be created by assigning any pointer to it. You can then query the any type for the type. Can I? I feel like this is what we need in here, honestly. Yeah, so let's actually use any, right? So, okay, I like that, right? So if you need like a hardcore dynamic stuff, you can actually kind of do that in C3. I didn't expect that, honestly. Any, are you okay? Any, are you okay? Yeah, it's like a type def void star var in libcello. Yeah, exactly. It also gave me like a similar vibes. That's kind of funny. All right, so I think we created the like one operation in here, right? So you have an interface future, but on top of that, you can combine them, right? You can sort of combine them. So that's pretty cool. But like I like then to be a method of the future. I would really love this thing to be a method of the future. And maybe we can actually kind of do that, because as far as I know, you can define like a macro methods on types, right? So that means I can just do something like this where I accept the self and I accept the f, right? And essentially what I want this thing to do is to create a then feature, right? A then feature where the left one is self. Might as well call this left one, right? So this is the left one. Left is, well, it's almost self, right? Anyway, so and f is going to be f, right? So this is how we're going to be constructing all of these things. And furthermore, can I just return a pointer to this? Well, I mean, this is kind of dangerous, but at the same time, we can make it inlineable in some sense. Yeah, well, okay, let's try to compile it and see if it compiled or not. Right, so it wants a semicolon somewhere. It wants a semicolon in here. All right, so, okay, so something about the data, 26. So this one has to be any. Are you okay? Any, are you okay? Chat, who said the any? Who? Okay. Why did you freaking do that? Well, you literally damaged my brain with a single message. Anyways. Annie, are you okay? Annie, are you okay? Are you okay? Annie, are you okay? Fuck! Fuck! Why did you fucking do that? Shit's just compiling. Shit's just compiling. Dub. Yisu. This is actually pretty cool. So that means we can combine all of that stuff. I'm still not sure about the lifetimes. Like, I'm still not sure if this is a good idea. Also, as far as I know, there is sort of like a add macros that inline things. And since it's a macro, it was never instantiated, so maybe it doesn't even mean anything. Right, maybe it doesn't even mean anything. So we need some sort of a future operations. Do you guys have any ideas how to like implement the future? We can implement some bullshit futures, right? So we can implement some bullshit futures that do some useless work, right? So for example, counter, right? So this is going to be counter, and it counts up until certain value, right? Let's do some IO. We could do some IO, right? But it's kind of difficult to demonstrate that. I want it to be visual so we can see things, right? I want it to be kind of visual so we can see things. We can do IO. We can even try to then integrate that thing into our networking library, right? So, but again, it means that we have to like dive deep into rabbit hole, right? So I don't want to do that right away until we got all of the things right. Anyways, okay, so we got that. And this is the future, right? So this is going to be a counter, and it's going to have the current value, right? So it's basically I and n. Well, let's combine them together, right? So, and what it does, it just like counts things, right? So that's what it does. Nothing particularly special, it just counts things. And let's go ahead and implement the interface in here, right? So it's going to be a counter. And if I, actually, yeah, this has to be self. And if self I less than self n, right, what we do, we're going to do IO, print fn, and this is, we're going to just like print the current I. And after that, we're going to increment this entire thing, right? We're going to increment it. So if it's greater or equal, we're kind of done, but we also need to return the result. What's going to be the result of this counter? I suppose we can simply return a pointer to n. So that's one of the things we can do. We can return a pointer to n. So this one is dynamic. Furthermore, maybe we can also reset this kind of thing, this kind of counter. So reset. Okay, so it acts like override, right? So because reset is not part of the future interface, right? And because of that, you don't have to put dynamic in there. Okay, that makes a lot of sense, honestly. That's actually pretty cool. I really like that, honestly. What the fuck? Let's go ahead and try to do something else in here. So in resetting is going to be just, you know, self I 0 for whatever reason. You just want to try that. Okay, so counter, and we're gonna say that we're gonna count up until 5, right? So we're counting up until 5. And look, while counter poll not equal to anything, and obviously it may return an error, so you have to kind of unwrap it, right? And then we're gonna check that. What we're gonna be doing, we're gonna be just polling this entire thing. We're just polling it. So let's go ahead and try to run it. So what does it say? Missing return statement somewhere in a poll. Yeah, okay, so that means here I have to return null. There we go. Okay, so counter, one more argument. It wanted one more argument. Okay, so because it's additional data, let's put null in here. It doesn't need additional data in here. Okay, so it counted from 0 to 1 and stuff like that. So yeah, it seems to be fine. Seems to be fine. What we want to do now, I want to actually chain it with something. So can I do something like then? Right, so and left one is going to be a counter, right? Left one is a counter, and the f is going to be a function that obviously returns another feature and accepts some sort of any data, right? It accepts some sort of any data. And what if we want to kind of finish the whole thing? So maybe this is where done is going to go into the place. So I want to return something like done, which just returns this data. Because the thing that I want to actually do in here, I want to do IO print fn, just print the data and see what it is. So if I understand correctly, any stores the runtime information, right? Any stores the runtime information in here, so which we can inspect and stuff like that. At least this is what the documentation says, right? So at least that's what the Okay, so we can even say the counter has finished. We're gonna make a JavaScript out of this motherfucker. We're gonna make a JavaScript out of that. I'm telling you. You think I can't do that? You think you don't know who Zozin is? I'm gonna fucking make a JavaScript out of that. Anyway, so the counter has finished. The type of result, and I think this has to be called result actually. The type of the result is this, right? So that's the type of the result, and then we say that this one is done. Done. Sorry. By the way, I'm thinking that maybe we should not indicate an error with a poll, right? Maybe error should be one of the things that the future becomes, right? So the state of the future, so to speak. But that means that we have to introduce another sort of method in here, which is a pain in the ass. So I suppose we're not going to do that. Yeah, let's not do that. Okay, let's create a done future. Right, so it's going to be done future, and it's going to only contain result. Right, it just contains the result. And the method, right, so it just polls like this. Done. So I have so much brain rot on today's stream. It's a done, and Ani, are you walking? So the brain rot on today's stream is insane, honestly, right? So that's basically the entirety of the thing, right? So done just does this, right? Done just does this. So that's basically what I would do. I don't want to take a pointer because I want to see how the compiler complains, right? I want to see the compiler complaining and telling me what exactly I need to do in here. Right, so this is the then, right? And what I want to poll now, I want to poll this thing, right? So this thing is going to do the following thing. It's going to just call the counter all the time. Then when the counter is finished, it's going to call this function that will return a new future. But since we don't need to continue doing anything, it will just return done. Right. ED works. Yeah. So ED actually works. We recently implemented the ED editor with the bot, right? So everything works in there. Anyways, so obviously it doesn't compile, but it's only syntactical errors, honestly. So I have to put semicolons in here. So I want a semantical errors. You can only convert to interface pointers. Okay, so that makes sense. So that means I have to take a pointer to here. That makes sense. So data could not be found. Did you misspell it? Yes, in fact, I did misspell it because this thing has to be called result. That's what it is. All right, another one. So it has to be a pointer and it has to be double pointer. So pointer to a temporary function once they returns. A pointer to a temporary value will be invalid once the... So, okay. The lifetime of a temporary pointer is actually like one thing in here. So, and it can check it in here, but obviously when you pass it into the function, it's kind of difficult to check it. So I think that was an undefined behavior actually. So the thing that we talked, the thing that we talked about at the beginning of the stream, I think it was like literally undefined behavior. I called it. I think it was. Right? It's just, it was difficult to check it. Right? It was difficult to check it semantically, but I think it was an undefined behavior. Yeah, because we don't have a borrow checker, right? This is the kind of stuff that borrow checker is supposed to catch. Yeah, literally, borrow checker would have caught that. Unironically, it would have caught that because it's specifically designed for these kind of situations. Right. Rust is nuts. Yeah. Anyways, so what we have to do in here, honestly, we can just like, I mean, we can always create a bunch of things in here, right? So, so that means we can, if we want to be dynamically allocating different tasks and stuff like that, different kinds of features, we'll probably need a dynamic allocator for all of that. But I mean, we can just allocate all of that shit in a dynamic allocator, literally. Can I do that? So can I have an allocator temp and just like say new, and then it will use the type of this value, allocate that thing there, and just move it there. Can I do shit like that? Does anybody know? I think that, yeah, like temporary allocators for this kind of stuff are gonna be like a lifesaver, honestly. So we got some subs, by the way. I wasn't paying attention to the subs. So thank you so much, Alex over 6 for Twitch Prime with a message. All right, so that's pretty cool. Okay, so I need to learn how the allocators work, right? So I need a method that just like allocates, just moves this thing into the heap or into the temporary, like just moves it somewhere. That's what I need in here, honestly. Okay, so yeah, you can't easily do that. You can't easily do that, mate. All right, so let's fucking go. 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 Allocators. So I think it's mem allocator. New. Maybe it's just mem. New. So there's a temporary. Okay. Okay. T-clone. Thank you. Learn. Thank you. There's just T-clone. Holy shit. Yeah, that's literally what I need. That's literally what I need. I'm so fucking happy. So that means I can just do T-clone. Yeah. All right. So fuck you. Oh, okay. You have to do mem. Okay. Could not be found. You have to put. Did you mean? Or maybe you have to put at in here. Ah. Okay. So this one has to be dynamic, obviously. Dynamic. Okay. Motherfucker just worked. What the? It outputted some bullshit that I do not fucking understand. But I mean, yeah, it's technically right. It's just type ID, and we can. Yeah, that's so fucking cool. Holy shit! We can actually now allocate everything dynamically. Just fucking allocate everything dynamically and put it into temporary memory. This is what we can do. So now the thing I can do, chat, is mem t-clone. and just move the counter there as well. Just move this motherfucker there. Just move it there, like so. So this is the counter. Just move it into dynamic memory, right? You don't have to worry about that motherfucker anymore. And now, within the counter, when the counter is done, you see how I return a pointer to its internal field. I want a copy of that thing, actually. In reality, I want a copy, so I might as well t-clone this motherflipper as well. T-clone. T-clone. Right, and all of that is in temporary memory, so that means then I can deallocate everything at once. It looks kind of ugly. I wish t-clone was like a little bit shorter. Yeah, so... By the way, like, I don't remember what exactly add does, but I vaguely remember it means an inline macro. It vaguely means an inline macro. So, and what inline macro does, it literally inlines the body of this thing, right? And has an access to internal variables and shit. I think that's what it is, or something like that. But don't quote me on that. Like, I don't remember the details. So clone is just like clones on the heap, and t-clone, you know, puts that in a temporary allocator, which you can then reset if you want to. All right, so if I try to rebuild this entire thing, it seems to be working. It seems to be working. And now, like when it's done, actually, I can do some interesting cool shit. So first of all, I want to make sure that the result type is equal to integer type ID, right? It is an integer, and it automatically like clones it. Or you can actually just do something like that. Okay, so we can do switch case. Switch result. And can I do case int? Right, and in case of int, what I want to do, I want to actually return a new thing in here. So this is going to be t-clone, and this is going to be another counter. It's going to be another counter where n is actually result plus 5. So it's going to count until 5. Then this thing is going to trigger, and it's going to update 5, and it's going to be another counter. So you sort of chaining the tasks and stuff like that. Right. In case of the default, I don't freaking know. We can just like return maybe a reject thingy, right? Some sort of a reject thingy that will store a fault of some sort. Right, but I haven't decided yet how we're going to be doing all of that. So it's kind of an interesting question. So we need some sort of a reject, but not for now. So I'm going to just put unreachable in here like this. But ideally, I would like to put a to-do saying that introduce reject future, right? Some sort of a reject future. So we don't need that. Right, and we don't need any of that stuff anymore. So that's an interesting one. So now it doesn't compile, obviously, but it's a pointer. Okay, so let's actually extract this pointer. All right. So it counted. That makes sense, right? It's counted up until 5. It got 5 multiplied by 2, and it continued from there. So essentially, I should have actually created something different. So I may say that, okay, I is going to be from where this thing continued plus 5, and then the maximum is going to be plus 10. Something like that. I think that's what I was going for. Yeah. As you can see, it's starting from 0 up until 5. Then it got the result of that thing, and then added 5 and continued from there. And then it continued from there. Right, so you can chain those things together. But furthermore, right, so you can think of this as just a future, right? So here's some sort of like a F1, right? And it's then, and you don't even have to think what it is, right? You don't even have to think what it is, it's just like F1. Right, don't even think about it, and it just works as it is. Then you can have another feature, right, which is also another maybe counter, like let's call it F2. Let's call it F2, and it's going to be a counter that maybe starts from 20 and goes up until 30, something like that, right? So here's the second one, and you can poll them now simultaneously. You can just poll them simultaneously. So F2, so this is the second one. So, and the way we're going to do that, if all of them return something, I suppose what we have to do, we have to stop, right? And so We can maybe do something like this. While not and not. How can I do that? I guess like that. Yeah. And now look at that. One future starts from 0, another one from 20, and they kind of go interleaved, and they kind of interleave each other. It's a Spanish language, exactly. Right, so maybe I can make this one a little bit smaller, right, 25. Right, if you only poll the second one, right, if you only poll the second one, it goes from 20 to 24. If you poll only the first one, it does this thing. It's two futures, right, like this. But then you can now start polling them simultaneously, right, and they start interleaving, kind of. Right, it has to be or, yeah, yeah. So I need to actually do them simultaneously. So the way you do them is just like this. I'm just thinking what's going to be the best way to do that, right? So you can have like a result 1 and any result 2, right? And you only quit when all of them are null, right? You quit them all of them null, right? So R1 equal null and R2, not really 2, but not equal. If both of them are finished, right? If both of them are finished, only then you kind of break. This is what I'm trying to do, right? This is what I'm trying to do. So, oh, by the way, I confused them. So what does it want? Cannot convert Boolean to any. Is it Boolean? Ah, yeah, that's what I'm doing. Yeah, there we go. So now they are interleaved. So now they are interleaved. Right, so that's how you can sort of execute this asynchronous future simultaneously, right? So because they always do work in a little incremental, chunks. Right, so since they do work in incremental chunks, you can just do that simultaneously, like almost simultaneously. So, and because all of that is interfaces, right, it's all dynamic, we can simply put that into a huge list of futures. Parallel, but not concurrent. Actually, this one is concurrent, but not parallel, right? So this one is more concurrent, right? We do that on a single thread, right? So this is a single thread. So in here, we have a bunch of futures, which we can then append, right? So futures, push, and taking a temporary reference is actually kind of bad. So you have to clone them into temporary memory. And cloning them into temporary memory kind of sucks, honestly. Look at this syntax. It really freaking sucks. I don't like it. So here's the futures, and we just push them in here. So essentially, what we do, right, is just do that but on a bigger scale, right? So we do for each, right, for each future in futures, like so. We're just freaking polling them, right? So we're just polling them, but we also kind of need to collect the results, right? So we need to collect the results. So this has to be unwrapped. We can make something like any results. So results push like this. And every time we do that, by the way, we probably need to reset the results. I don't know how to reset that, but I'm gonna just do it like this. And at the end in here, we just check in all of the results, right? Results. And yeah, if any of them, if all of them are, yeah, if any of them are null, we have to continue. So let's actually do something like, quit. It's going to be quit false. And essentially, if result, what's funny is that we can do that in here. If result of any of these things, equal to null, the quit must be false. Initially, we say it's true, right? But then we try all of these things, and if we encounter anyone that is not finished, we'll have to go for another round. Because of that, we don't need this list, right? So I think that's how it can work. And Yeah, it didn't work. Right. So yeah, some of them is null. I suppose who returns null? I'm actually curious. Who returns null? I think none of them should return null. Does C3 have all or any of? Maybe some of them, right? So yeah, this one has to be quit, not quit. There we go. Yeah, so now it works. Now it works. This is what I wanted, essentially. Okay. So, but here's an interesting thing. This looks like shit. Straight up. This straight up looks like shit. The thing I want to be able to do, I want to be able to at least then a little bit easier. Right, so instead of doing this kind of shit to just then a thing, I want to be able to maybe, just like in Rust, then, where I can then put a function like this. And I feel like I can do that. I do feel like I can do that with a macro. There should be some sort of a macro that allows me to do that. There should be something in here. So another syntactical atrocity is tclone. It also looks like shit. I think constructing these kind of things should be way simpler. Make future macro, yeah, so create future or something. So we'll see. All right, so let me see how we can do the whole thing. Right, so far it works. And so this is then, and then here I'm gonna just like literally create a macro. So future, I wanted to work on any sort of future, right? So this is going to be then, it's going to be function, maybe macro specifically, right? So we're going to construct it as a macro. And so accept the left one and then function, right? So this is f. And in here, we're going to return also tcloned, right? So it's going to be tcloned because we want to allocate it in temporary allocator. And right now we're allocating everything in a temporary allocator. But in the future, I think we can make it customizable, right? So because I think you should be able to just like choose where exactly you want to allocate all the dynamic stuff. Right, so this is going to be then in here, you do left equal to left, then f equal to f. And that's it, that should be it, I think. Right, and I wonder if that's going to work, right? So let's actually grab this stuff, then do then, and put this stuff, because that already looks like JavaScript, right? So that already kind of looks like a JavaScript. And let me actually maybe, you know, comment this thing out, right? And let's just say futures push, like so. I'm going to push it. Let's take a look at how compiler is going to compile. Okay, it didn't like that I forgot semicolon. That's fine. That is totally fine. Anything else? Macro method is already defined in future. Is it? Oh, I already did that. Ah, I forgot. I was just... All right. That happens to me, actually. That happens to me. So already implemented it, but I thought I didn't implement it. Right, so, okay. Whatever. I think I was writing this code as sort of like, this is kind of like a pseudocode. I'm not sure if it's going to work or anything. Right, I think that's what it was. Like something sometimes in my brain. Dimension, like, I mean... Anyway, maybe I'm just a little bit tired. There's no field for or method for counter them. Seriously? That is actually kind of sad. That is honestly sad. But can I cast this entire mother flipper to future? How do you cast things? How do you cast things? I forgot actually. Cast. Pointer cast. Oh, it's like in C. Okay. Can I just do future like so? Are you going to work, my friends? So, but maybe this is what we have to do. So future cannot be implicitly cast to future, but you can use an explicit cast unsafely. Future. But that's what I wanted. I actually wanted pointer. Cannot be. What? Cannot be implicitly cast to future. What the hell are you talking about? Is that because then? But it's a point. I expected it, bro. What are you talking about? Am I going crazy, or do I have to do explicitly future? Well, at least it compiled. At least it compiled. That's already something. That's already something. So, but maybe we don't have to do this kind of shit. So it created out of bounds situation. Yeah. So you have to. Okay. Okay. We can do something like make future. Somebody suggested make future, but I don't like it either because it's too long. Right. We can do something like but we can put all of the futures into what is it called? Module, right? Make VTR, yeah. Make VTR. So fn, and it has to be a macro, right, of some sort, and this is going to be, it's going to return a future, right? So it returns a future, and the like a value of some sort, right? And the thing I'm thinking about is just like do it like that. Yeah. Make of t. So now it's just make of t because I wanted to, yeah, clone, and obviously it has to be semicolon. Holy shit, it worked! Fuck yeah! Fuck yeah! Fuck yeah! Fuck yeah! Fuck yeah! So yeah, and because of that, by the way, we can do cool shit like make of t, right, like this. Now it's a counter and shit, and obviously maybe I want to actually put it like that. Introduce reject. There we go. Yes. So that makes it easy. That makes it easy. So you can, you know, chain them and everything. You can actually chain them. I wonder how, like, what exactly we can do. So this one is not needed. Fuck that scheiße. Fuck that scheiße. Fuck that scheiße. So can we do some funny shit? For example, futures push make of t done. Right, so it's going to be done, and the data it stores, you know what, I think I want to call it Dean, sort of like dynamic, because you can all use it not only for futures but for pretty much anything, honestly. But sometimes no. Yeah, so I want it to be dynamic, and then I'm gonna have a macro future, right, that just returns future but calls dynamic. So dynamic is for any sort of values, and the other stuff is for, okay. So by the way, why did I have this hard-coded? Am I an idiot? I think I'm an idiot, but whatever. So I feel like maybe I can even define Dean as just this, right? And I'm not sure if it's a good idea, but in here I can do Dean value. Can I do it like that? I think I should be able to do it like that. So in here I want to just do 69. Alright, so semicolon, that's fine. Is that the only thing you want? Yeah, you can't. Add macro, you can do the aliased. So did it say remove? So maybe I have to remove this kind of thing. Alright, so add macro, so just like make a macro. It accepts the value, but it returns the whole thing in here. Return, please. Okay. And I think now it should be kind of work. So there's no make of t because this thing is more like a future. Right. So int any, and this one is going to be dynamic. This is why I want to, yeah. So because the dynamic is just for values, futures is specifically for futures, and you need separate things in here because you need to cast them to a specific type. So then later you can do then on them, right? Otherwise it's not going to work, right? You can do something like that, right? And it's going to be future done Dean. Furthermore, you may actually have macros that are just done. Macro done value, it returns a future, and it's just something like this. So return Dean value future done like this. So this is what you can do. So effectively this is simply done 69, then here done 420. We can now chain this entire shit. We can do something like IO print fn. I wonder if we can just do something like s result, and then we can essentially just do done for 20. After that, we can continue chaining all of that stuff. I think that's what we can do in here. Just a second, give me a second. So that means we should be able to so this one, does it close? Yeah, I think I forgot to do this thing. So I should be able to do another then in here. Future any result, future any result, and here we can do that. And then 137. But we have to return them. Yo, I think we should be able to do this kind of stuff now. That's actually cool. It's actually super cool. So tuck away all of that shit into different sort of macros and stuff. I think that's a good idea. Let's fucking go. Let's go through the compilation errors. So there's some things that we need to sort of fix, but it doesn't matter. 83. So there's just typos. Okay. So there's no field or method then. Okay. That is very interesting. So then actually, okay, I see what's going on. The macro then must return a future. Okay, so there's 86, another. So you can chain them, actually. You can actually chain them. That's actually super cool. But it didn't print the last one. You can chain another one, and you can just say, okay, done 0. Right, so because here is done 69, then done that, done that, and then you just like sequentially print them. But this is just a single future. And again, you can just add a counter that counts from 20 to 25 and to not include that. Right, so here's the counter for 20 to 25, and here is the thing that chains them together. Right, chains them together. We can put them into the same pool. And they're gonna be interleaved. Fuck yeah, it works. It works exactly like futures. Like you can actually do asynchronous stuff with them pretty comfortably, actually. Look at that shit. So you definitely probably want to have like a counter maybe as a macro, so it looks it. Man, so with macros you can actually even make it look nice. What the fuck, bro? You know what would be even cooler? To not print this future thing all the time, but I think you can't kind of avoid that. See, macros are not bad. Yeah, they're actually kind of good. All right, I can now see where all of the C3 budget went into, right? So again, C3 is kind of like a weird language. Like some parts of it are amazing. Some parts of it is just like, what the fuck? What were you smoking? Please give me some of that stuff. This would look 100% worse than Rust. Yeah, but the thing is, it uses a lot of like dynamic things. Right, and Rust is trying to check as much as possible at compile time. So here, we literally pass in void stars all the time, right? So we literally pass in void stars, which is like a very dynamic thing. So yeah. Anyways, so it's kind of cool that methods can be also macros. Just think about that. Methods are also macros. It's just like doesn't matter. I fucking like that. I freaking like that, bro. Okay. Yes. Let me see. So where's the counter? So you have to create. If you're creating your own future, right? If you're creating your own future, you have to implement all of the methods and stuff like that. But you also have to implement the constructor for this thing, right? Otherwise, it's just like not convenient to use. So the thing you have to do is something like future counter, and it's a macro, right? It accepts I and n. Right, and it should allocate all of that stuff dynamically, right? So this is going to be future counter counter, as we can just put that I and N like this and just return that. Look at that. So let me try to recompile this entire stuff. So it's not a count per se, it's a counter, and it seems to be working. Look at that. So I'm scheduling this future that counts from 20 to 25, right? So, and then another future that accepts 69, then passes it to this one, then another one, then another one, and another one, right? Interestingly, like I said that I wanted to have also a reject future, right? I wanted to have some sort of a reject future, So what it should accept, I think it should accept some sort of an error, right? So, so because through a poll, we also return error, right? Some sort of error in here. So I need to somehow be able to store those errors, but I don't really know. Right, so error, essential error handling. So the question is, how do I store? So here's the excuse. But then I want to say, I don't even know, man. I don't even know. Can you store them as well? Okay, so C3 fault. Does anybody know how to do that? So because essentially what I want to be able to do, I want to be able to store a fault in there. Right, and it's just maybe excuse, maybe error. Yeah, and when I construct this entire thing, let me try to construct it. I'm going to try to construct it maybe somewhere here. So here's the reject, and what kind of errors can we have in here? I don't know. So I remember there was an IO error. I think would block, right? So, and I think that's how you do that. That's how we construct an error in here. So invalid member has a yeah. Can I store errors somehow? Is that a thing I can do? If I just store it as an integer, okay. So would block has no error value. Why did it fail in here? The expression may not be optional, but was... I think I broke something within the compiler by just doing that. Holy shit. What did I break there? Anyway. So how can we report an error? Block or build? Would block. Well, I mean, yeah, so would block. So it's not possible to cast from this to this. Yeah, there should be a way to store errors and rethrow them later, but it feels like you can't easily do that. I don't think it's a use case in here. Unwrap an optional. So let's find the faults. So faults, let's read about them. That's not what I want. Faults. Enum faults value. Okay, so this is what I'm talking about. Enum and fault values follow the same naming standard as global constants. Understandable. Is that it? You're gonna give me more information about faults? Okay. Optional type, optional excuses or type. Okay. So optional excuses are of type fault. So there is a type fault. So when an optional does not contain a result, it is empty. It has an excuse which is a type fault. So you telling me I can use fault as a type. I can use fault as a type. So let me quickly do that. Where's the reject? Can I just say fault? So you say it has a type fault. How can I use a type fault? So like the type ID, the constants. That is interesting. Type fault. But I can't use that. Sounds like a result type. Well, I mean, I need a specifically error of the result type. I don't need the result type itself. I need the error of the result type. And I don't see an obvious way to just do that. Where is the obvious way to just do that? Like, I want to store it, and so then I can rethrow it later. And I want to throw it by its own. Fault reject, you don't understand what I want. I don't want fault reject. This is not what I want. So it's a bit ugly, but you could store it in int and only... You can't do that. I just tried that. That's the problem. You can't store it as this. You see, valid. It's an invalid member. It has to be a member of the structure. I think something missing in the design of C3 in that specific regard. Something like there's a hole in design in the language that doesn't, like, I'm soft locked essentially on this. I want to be able to store a fault so then I can rethrow it later, but in a structure. Any type, okay, we can try any type. It's kind of weird, but I mean, you need to add the trailing. Okay, so cool. Yeah, you can't do that, right? It's just like we're soft locked essentially on this one. Oh, it's even not possible in Zeek. Why nobody thought about it? This is actually like, this is kind of useful for futures, right? So because if you're, yeah, you want to create a future that always fails, right? So if you're making this sort of interface, right, so where poll would fail, you want to create a future that will fail with a certain error, right? So to distinguish between done and reject. You know what I'm talking about? All right, so that's kind of a sus, honestly. Add a catch future, store error in a custom struct. This is literally what I'm trying to do. Goofy chat. Anyway, so we need to think. So, all right. So let's try to grab maybe fault. That's actually kind of disappointing, honestly. Fault, you can't store faults. So fault can be an enum-like. It's not an enum-like. Fault is its own thing. That's the thing. It's its own thing. What's funny is that the annoying thing is that, like, you can store int x like this. Like, I'm sure you can store that. So it will complain that, you know, I didn't provide the question mark. Okay. Okay. Future was not. What did you say? Ah, okay. So that's understandable. So 19. Yeah. This is fine. You can store an error or a fault. Any fault. So there is any fault. Oh my God. I missed it. This is what I was looking. Look, why? I think documentation is not updated because somewhere in documentation it said has a type fault. I suppose you meant any fault. Right, so documentation was confusing. Look, you guys saw that. Somewhere in some of the documentation page it said this thing has type fault. No, it has any fault, right? Or like, I don't know, it was confusing, right? I was trying to figure out like what I have to put in here. Right, so any... Finally, it even highlights it. Okay, finally, Jesus. That was not obvious. Very not obvious. Okay, so reject, and in here, what I want to do is just like a IO error, would block. Yeah, I think that's it. So let me see. In future, it wants to poll, obviously. Right, okay. So, and here reject poll. So that means the design is not unfinished. So there is no hole in the design. Okay, that's cool. So, and in here we return any, and that thing always returns an error. Dynamic. It always just does error. And I wonder if I'll have to put question mark in there. We'll see. Expected. Oh, just a second, guys. Cannot cast any fault to any error. Boom. Hell yeah, brother. Hell yeah. Okay. So yeah, and essentially, so we can now have rejects and shit. So where is the done macro? Where is the done macro? I want to move that done macro closer to here. And we're also going to have a reject macro. So this is the reject macro. Reject. And by the way, we don't have to do daemon here. It could be just an excuse. And we can say it's any fault. So something like that. So that's what we want to be able to do. We want to be able to just reject things. So futures push reject and IO error would block. Okay, so I should be able to do this kind of stuff, right? So I can say reject, right? And that will be rejected later. Okay, so value 35. So this needs excuse. And futures. This result we call optional. Really? What the fuck are you talking about? Excuse me. Do I have to put expected future, not can I just right. I just want future. So something with the syntax of C3 that just doesn't allow me to easily do that. So it considers some of these expressions as errors. So there's a little bit of an error propagation going on that kind of fucks everything up, and I don't really know what to do about that. So what does it say? The result of this call is optional. Yes, well, not really. That's annoying, bro. That makes it insanely annoying. Because if something is internally optional, the whole expression is kind of optional. You know what I'm talking about? It's just like, it's so annoying. Like, it considers this entire thing optional. But it's not. Like, I just want to store excuse inside of the error. That's what I want to do. That's it. Like, it doesn't allow me to do that. But to be fair, it's something with this. I don't even know what's up with that, but it's just like annoying. Alright, so this is annoying, bro. Bro, this is annoying. I don't even know what to do with that. Broski. Yeah. So it's kind of difficult to reject these things. It's kind of difficult to reject. Maybe we just don't have to use the error mechanism, but I mean, error mechanism is how you do errors in C3. Maybe it needs to be a proper method instead of macro. What proper methods? No, it doesn't have to be that. We're constructing. This is a constructor. It's a constructor. What are you talking about? You don't understand what you're talking about. All right. That's annoying. So because there is this stupid propagation. There is stupid propagation of errors. Is that when you have like an expression that looks like this, if this is an excuse, the entire expression is considered to be excuse or fault or whatever, right? So it kind of propagates to the entire expression. And because I'm trying to store this excuse in here, it kind of propagates to the whole thing and it fucks the typing up. It fucks the typing up, and this is just like really, really annoying. It's really, really annoying, and I don't really know what to do with that. So yeah, maybe I'm gonna just like postpone that for a while. Let's not do rejects. Let's not do rejects at least for now. And yeah, so at least the sort of like a base isn't there. At least the base isn't there. And to be fair, you don't even need that many things. You don't even need that many things, right? So you need then macro, you need done, you need reject. Eventually, it's kind of annoying to implement reject. Right, and then you can easily compose futures together with thens. Right, you can just like now compose them together, which is rather useful, honestly. It is insanely useful. So, and yeah, in the future we can even apply that to our networking library. So we can have operations that like read a buffer, and it's gonna be a future that until it's finished reading, it's not gonna do anything. And then you can do, and then you can process the buffer that you got from the previous future, then schedule another task, and so on and so forth. And it's going to be like a very much asynchronous library. So that's actually kind of cool. That is actually kind of cool. So, but I would like to make a small break. I really want to have reject, because without reject, it actually doesn't. It's not going to work that well. It looks really good. Yeah, it's actually awesome. Like I didn't expect it to be this close to something like JavaScript, honestly. Better than JavaScript. I don't know. Like, I mean, yeah, I agree. Anything is better than JavaScript. Ah, got him. So maybe we can even do something like that. Is that something that we can do? Yeah. So let's make a small break. Right. After the small break, I'm gonna try to see what we can do with rejects and stuff. Right. So I just realized that maybe there is some usage of any faults in the standard library. Let's actually freaking grab that shit. Grab any fault, let's go. Do you have any faults? Okay, so there is some, look at that. Okay, so this is what the chat was talking about in the break. You can store shit in here, so we can try to see how they set that first fault. How do you fucking set that? How do you fucking set that? Okay, so they're rethrowing it, that's understandable, so... And then first fault, how do you do that? I don't see it being assigned. Here is an assignment. Fascinating. Fascinating. I think that's what's going on in here, chat. Maybe that's how exactly I have to do that. So reject and... did I already remove reject? I think I already removed reject. Okay, let's actually quickly implement that one more time. One more time. What was in this too? Anyway, so reject any fault excuse. Right, so this is going to be excuse. Excuse. This one is reject. Then we do excuse. We rethrow that mother flipper like so. So, and the final thing is we need to make a macro reject, right, which accepts the any fault, right? So, and this is going to be excuse. And I suppose the stupid shit we have to do is reject R like this, and then I have to do R excuse, and only then I have to do T clone of R. Is that how I'd have to do that? But it might be not the case. Okay, so first error. How do you call first error? Like, I'm really curious. First error. Okay, so you just do it like that. Okay. Futures push reject IO error would block. Would block. Wouldn't block. Yeah, wouldn't block. And let's try to build the whole thing. Nah. Bro, nah. Bro, why? Okay, so here we have to return first of all future. Right, first of all. Maybe this has to be a function. Okay, so let's try to construct it as a function, not as a macro. Maybe it's macro that fucks everything up. Maybe that's the case. Because there are other things on there. Okay, so reject cannot be implicitly cast to future. It can be. It must be. How? How on earth? It's a pointer. It by definition can be cast. Ah, I forgot to do this. Okay, so this is the future. Okay. Fucking do that. Yes, you can do that. You can fucking do that. Yo, you can actually fucking do that. Holy shit. Holy fucking shit. We don't even have to like, you know, 100% like fail in here or anything. We don't have to like panic. We can store both results and failures. It makes it super convenient, right? So to fail somewhere, right, so you can remove the counter, right? You can remove the counter and you can put reject at the very end of this thing. Right, so here we go. You have a chain, you put 69, right? Then you print that 69, then 420, then this one, and at the end, you would actually, you know, fail with wood block. Right, you can do that, and it's totally fine. And that's exactly what happened. So this is straight up a library. This is a straight up a library that you can like conveniently use. So I think we don't need these things anymore, because since all of the creation of the macros of the futures is tucked away into their own macros, we can get rid of these little things, right? So I'm going to show you like why. Right, so for example in here, 2021, we can just like directly call this thing like that, and it's not going to look ugly because it's tucked away by the done macro anyway. Right, so it doesn't matter, right? So we're tucking all of that away, so it doesn't matter anymore. There we go. So, and it seems to be working, right? So this is basically a library. I can now factor it out to a separate maybe structure. Let's call it future. Right, so future C3 is going to be module future, like this. And let's just copy paste all of that stuff in here. And yeah, so the name is too huge, honestly, right? So, and I don't really know what to do about that. But we can move some of these things in there, maybe except counter, right? Because counter seems to be very specific. But things like done, reject, then, they seems to be generic enough so they can be useful for everybody. If you need specific, very much specific tasks, you just implement them like this. Right, so since I moved it into a separate module, now I have to like update some of the code in here. So now I'm going to import future. Right, and what we're going to be doing in here? So if I try to build this entire thing, it needs a future C3, right? So future C3. So what does it say? Yeah, and the problem here is that now I have to prefix all of these things. Thank you so much, learner. Very cool. Future done. Future reject. Yeah. Interestingly, can I just turn this into macro as well and just get rid of this stuff? You know, the bro. Do you guys remember? This is actually, yeah. There were macros. Yes, you can. Yeah, Siphon knows what I'm talking about, right? So because he also knows C3 really well. That will be even cooler. There are macros with custom bodies. Right, so let's actually learn about macros. Searching for macros. Okay, so maybe I have to refresh this entire thing. No, it doesn't work. Is that because I had to actually turn off the Ethernet, the web VPN? Bro. C3 is banned in Russia. Look at the iterator. Yeah, okay. I turned off the VPN on the break. Learner, why did you ban Russian IPs? So who banned them? Is it like, I doubt my government banned them. Maybe it's C3 who's just like, why do you hate me so much? Does it open for everyone else, or is it only me? Or is it just like, I don't fucking know. C3 might be using some sort of a proxy, yeah. Bro, for real? Works fine. Okay, so that means it's my on my side. So the same thing happens with Blast, as far as I know, in Lepak, right? So their website, they just like hang, right, until I actually turn on the VPN, and I don't know. Doesn't block me, just Russia. I don't fucking know what's up with that. So maybe it's using like a Cloudflare. Okay, so if it's a Cloudflare, it could be actually Russian side blocking some of the Cloudflare service. So this is more coming from Moscow. Okay, I see. That means it's something with Russia. It's either Russian side blocked some of the Cloudflare, or Cloudflare automatic some sort of a policies actually, like, you know, hanging the Russian service, Russian APs. How am I supposed to even work in these conditions? I don't fucking know. Anyway, whatever. What I wanted. Macros. The hash map iteration shit. Alright. Hash map iteration shit. Okay. So there was some iter, I think. Or was it... I don't remember how it was called. But it was something... Was it iter? For each? Was it for each? I don't remember the name. Each entry. Okay. So this is how you do that, right? So you can make a macro, an interesting macro that is like this. It's kind of weird, like syntactically. I don't really understand why it has to be like that, but okay, whatever. And you can specify a body, right? So, and then you can embed that body in here somewhere, which is kind of cool, I think. Which is kind of cool. So we can try to do that specifically. It's called each. It's called each. Well, I mean, whatever, right? So you can do it as well in here. So each entry or whatnot. So let me try. So it's going to be future. And instead of then, we're going to have something like this. So this is left. And then it's going to be body, right? So hash map body. Right, so this is body. Do I have to have it name? I don't know how to call that. Then, can I just call it then? I should be able to call it then. So fn future, because I don't want to type all of these boilerplates. So then data. So it's gonna also hide a little bit of data, but maybe that's fine. It's not void star, it's any. I don't really like that it hides this information. So I'm not sure how good of an idea that is. But anyway, so it's body, then. Alright, so and if I try to now just build the whole thing in here, so they have to put some, yeah, apparently I have to put some colon. Okay, so then did you misspell? Okay, so we are getting there. So theoretically, now I should be able to just do something like this and just that. Will that work? Where's my compilation? So do I just do it like this? How do you use that? I remember usage of this thing was kind of weird. I think I can get that in coil because I used it once in coil. So let me quickly do that. Let me find this thing in coil. Oh yeah. Oh yeah, oh yeah, oh yeah, oh yeah. So, and this is entry. So, I see, I see. So, and the entry is the name of this thing that you can access in there. Okay, that makes sense. That makes sense, that makes sense. So that means here, this is not really then per se, but it's a result. Right, it's a result. And if I take a look at the hash map, we don't really specify. Yeah, I see. Right, so it's a result. And here we just do a result. And I put that result in. Okay, so that starts to make sense, actually. That starts to make sense. And in main C3, so what we're doing here is any result, and I'm going to sneeze, by the way. Thank you. So let's continue. So something like this, right? So that's how it's supposed to look like. That's how it's supposed to look like, chat. So now let's try to rebuild the whole thing. Yep, so it's complaining about some stuff. Then future has no method then. Did you misspell it correctly? Ooh. Yikes. Why don't you allow me to do that? So maybe, oh, maybe I have to now do that for all of them. Okay, okay, I see. I think I see what's going on. I think that's what I have to do now. So in this one, obviously has to be closed like this. I'm not sure if I can now chain them very easily. It looks actually uglier than it was before. I don't like the fact that it looks uglier, but I mean, this is something that I probably can't fix easily. Yeah. So is that better? Is that better? It actually looks ugly, honestly. I don't like it. I don't like it, but let's give it a try. Let's give it a try. And so body could not be found. Did you spell it right? I'm pretty sure I spelled it right. I didn't think it's gonna cut it. It looks worse. Yeah, so these macros, I didn't like them when I used them for hash maps, just standalone. I still don't like them when I make my own ones. They look ugly. They're just like, nah. I think they're a huge mistake. They're actually a huge mistake. So let's actually go back. I suppose this is what we have to do now. Right, so let's just use whatever we had before. Don't like that I have to put this boilerplate with fun and whatever, but I mean, looks like I don't have much choice anyway. Yeah, so that seems to be working. Seems to be working. So I'd like to maybe try to apply this library for my networking library. I wonder how difficult would it be. Yeah, so we will need a bunch of operations. We will need a bunch of operations like read buffer, read entire buffer, write entire buffer, and so on and so forth. But that will require rewriting a huge chunks of the library itself, and I already kind of streamed for too long. I think the outcome of today's stream is going to be this little small library for defining like very simple features. Maybe another thing that would be nice to have is just like tuck away this loop, right? So essentially you just schedule a bunch of features and you just run them and it runs this loop automatically for you and either return success or not. So we might as well even, I don't freaking know, just like, so future start, right? So let's have a function start and this thing may return an error or not, maybe, I don't know. So because what if several futures return an error? What if the several futures return an error? So catch close, we can have a catch close, but probably later. So that will require creating a new kind of future, first of all, right? So that, yeah, and also a special macro catch. We can do that, but I mean, it's not needed right now. Right, so the thing I want to do right now is just basically start, and here we're going to accept a bunch of futures, right? So here's the futures, and it's going to be a slice of them. So the question is, like, what kind of error do we return even? What kind of error do we return? So I can just put it like that. So, and I just created a bunch of futures like this, and I want to be able to take a view of this thing and just do future, yeah, future start like this, and maybe unwrap the whole thing. So because one of the things we can do in here is just like if any error happens, we can just stop immediately. Any futures fails, we stop immediately, all of them. So that's one thing we can do. Right, so let's try to run that. So there is no view. Let me go to c3 lib, c3 std collections list. How do I take a view? A view, array view. Okay, so fair enough. We can call it array view if you want to, if that's your thing. All right, so that seems to be working. Right, so now we tucked away this entire loop, and it's going to block, and it's going to poll all of your features and stuff like that. So you can also do push counter from 1 to 5, like so, and that should happen simultaneously, so there is no foot. So that's understandable. It just has to be t clone. Right, we do t clone, like so. It's kind of cool, actually. Right, so it didn't go up until 5. Right, so we can actually say count up until here. Yeah. So they were interleaving until the feature that was outputting 69 for 2013 actually killed the whole thing. I'm not sure if it's a good idea generally, right, to do it like that, but I mean, that's one way to do that. Right, so it's not like a final implementation of the library, it's just like a library. Might as well even maybe create a repo for that. How should we call it? So latest sub is an expert in futures. Thank you so much for Futanari. Futanari. So do we have any experts on promises as well? All right. Okay, so anyway, I guess that's it for today. Thanks everyone who's watching right now. Really appreciate that. Have a good one, and I see you all on the next recreation programming session with a Mr. Azuzin. I love you. Mwah.